Hello and welcome, guys. You're watching my channel Engineering Study. Today is a lecture number 2. I learn you basic electrical engineering. So in previous lectures we discussed some basic parameters of the basic electrical engineering. Now we study that what is electrical energy, what is a potential difference, what is a current, what is a charge, what is a power across the ACs and DC circuits. And we see that these are resistors across time varying voltage. And now in this lecture we discuss capacitors across time varying voltage. As you see that the capacitors across time varying voltage. Okay, from the diagrams you see that this is a time varying voltage. That is a source voltage equation. You can write this. Okay, that is a Vs, and these are as according to Ohm's law, where the voltage exists there must be a current in that directions. Here is a capacitors. Okay, you see that here is a capacitors that is connected across a time varying voltage. There is a voltage drop across the capacitors because capacitors is a passive circuit element, and it is the properties of a passive circuit element is that when voltage is applied across it, then there is a some voltage drop across these passive circuit elements. What is the active circuit elements and passive circuit elements are already discussed. Now I again repeat it. Is a passive circuit element is that take energy from the source voltage, and source active circuit element is that deliver the energy. That in this diagram, alternating or AC or Vs voltage source is a active circuit elements, while the capacitor is taking energy from that source. So capacitor is a passive circuit element. Well, we know that when voltage is rise here, there is some flow of current in that directions. Means when we apply a voltage across the capacitors, then the charge is deposited on the place of the capacitors as the positives and the negatives. So when the voltage rise, then the number of charges are increases and more charge deposited on the plates of the capacitors. So it means that the charge is proportional to the VC voltage. Now, why we write this VC voltage capacitor? I don't write source voltage. Why? What is the reasons? Well, the reason is that when we apply a KCL law or KVL law, then this says that the voltage rise in a loop, that is a here loop is going in that direction from negative to positive, that is Vs voltage rise, and is equal to voltage drop, said positive to negative, so drop. It means that Vs is equal to Vc. So I can write this. It means that the source voltage here is equal to the voltage of the capacitors. So I can write this equation. Q is proportional to Vc, and Vs is equal to Vc. Here is the proportionality constants. I replaced proportionality constants, so I brought equality signs and proportionality constant. So Q is equal to CVC. Now what is the current in that capacitors? In that capacitors, what is the current? For current, here we see that Q is equal to CVC. If I differentiate respect to time, then dq upon dt and c dvc upon dt. So dq upon dt is the number of charges per unit time in a capacitors, that is the current. So current is c dvc dt. So current in the capacitors can be calculated with the help of that equations. If we take a derivative of the voltage across the capacitors and the capacitance of the capacitors, then we can find the current. Now I am go to calculation for the voltage. So this equation is rearranged as that dVc dvc and di dt upon c. Here is a differential voltage. Okay, that is a differential voltage, means it is a sub part of the vc. Here is not a total vc, it is a differential or sub parts of the vc. For example, when we write is a 5 is equal to 2 plus 3, and 2 plus 3 is the differential of 5. So here dvc is a differential of vc. I take integral, that is integrals. So here take integral, here take integral. Once is a constant, it's come out of the integral. So dvc of derivative is the total vc across the capacitors, and 1 upon c is f integral I dt is a current in that capacitors. So voltage can be found with the help of that equation 1 upon c integral of I dt. Now for the calculation of power, we know that power source where power delivered is equal to power consumed by the passive circuit elements, because the voltage source and the voltage also capacitor are the same. So PS is equal to PC, and PC is VCI, that is location for voltage source. And here current, we see that current in previous example, that is C dvc dt. So I put the values of current here, C dvc upon dt, and vc is already present. So c vc dvc dt, and power here dt is here, multiply it, divide it, and here multiply it, pc dt cvc d is vs. Okay, and it is a pc dt, it is the differential power. So for total power I take integral on both sides. So we see that here the total power and time varying, and c is a constant come out and integral vc dvc. So here's rules of the integral is that, so one quantity here is power 1 plus 1 is added and divided by 1 plus 1. Okay, so total energy c 1 upon vca or 1 upon cvca. So it is energy that is stored in the capacitor as electrical energies. It is stored in the electric field of the energies. Okay, in next lecture I discuss on the inductor across the AC voltage. For next terms, Allah Hafiz.